Hi, this is Mama Maths. Now let's talk about IMC. IMC 2020, question number 21. The diagram shows 4 semicircles, one with radius 2 centimeter, touching the other 3 which have radius 1 centimeter. So this length here is basically 1. This length is also 1. This length is 1, 1, 1, 1. So this radius here is 2. What is the total area in centimeters squared of the shaded regions? Now, notice that if you combine this one here, 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 and here, this becomes a rectangle with area 2 times 1, because this one is still a radius as well. So this area of this rectangle is 2 times 1, which is basically 2 centimeters squared. Now, how about the remaining areas? This one's here, here, here. If you combine all these images, it creates a circle with radius 1. So basically, that other area will be pi with r squared 1. So it's basically pi. Now, what's the area of the whole semicircle here? So it's pi 2 squared divided by 2. So basically, that is 2 pi. Now we will subtract the area of the rectangle and the circle. So 2 pi minus 2 minus pi will be pi minus 2. Hence, the answer is B. Okay. Next question, question number 22. So the diagram shows a regular pentagon and an irregular quadrilateral. What is the sum of the 3 morphed angles? Now, if you could see, any quadrilateral, its interior angles will sum up to 360. So this, and also this sum up to 360. Now also, this one whole lot is also 360 because the sum of an interior and exterior angle should sum up to 360. So basically, the angle here is equivalent to the angle here, the sum of these 3 angles. So all we have to do is to find the area of this, or the area, no, not the area, it's the angle of this one. So that's 5 minus 2 times 180 degrees divided by 5. So 3 times 180, that is 540 divided by 5, it will give us 108 degrees. So the answer is C. Now, you don't have to solve for this one if you know already what the area of or what is the angle of the interior of the regular pentagon. Okay? Question number 23. 5 congruent triangles, each of which is half a square, are replaced together edge to edge in 3 different ways, as shown from the shapes PQR. Which of the following list gives the shapes in ascending order of the lengths of their perimeters? Okay, so now it's different. They are not all the same. So this one is the hypotenuse. Hypotenuse is a side, side. Say this is side, 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 side. Hypotenuse, side, side. Side, 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 side. Hypotenuse, hypotenuse, hypotenuse. So basically, we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It will matter between these two because this side has only 1, 2, 3, 4, 5. So basically, the smallest would be P. So it's either A or E. Now, which one is longest between these two? If you notice, side is shorter than the hypotenuse. So basically, Q will be shorter because it has only one hypotenuse. We have 3 here. So question number 23, the answer is A. Also, you can also do that. If you remember, if you have 1 here, the hypotenuse would be square root of 1 squared plus 1 squared. You can also compute that, which give us square root of 2. Now, one application of which as well is when, regardless of what your number here, say 2, you just add the square root of 2. It will be the same. Okay, now going back, if you do this one here, this will give us, P will give us 2. plus 3 root 2. This will give us 6 plus root 2. And this one will give us 4 plus 3 root 2. So they are in ascending order from PQR. Okay. Question number 24. The positive integers m and n are such that 10 times 2 raised to m equals 2 raised to n plus 2 raised to n plus 2. What is the difference between m and n? Okay, now let's try to write this as prime factorization. You have, right, 2 times 5 times 2 raised to m equal to 2 raised to n. Let's factor out the 2 raised to n so that we only have the primes times 2 plus 1. 2 squared plus 1. Okay, I switch this to. Now, if you notice, 2 squared plus 1 can be written as 5. 2 times 5 times 2 raised to m. So we can cancel this out. Now, if we want to write it the same way, this is 2m plus 1, 2 raised to n. So basically, m plus 1 is equal to n. So the difference between them two is a 1. Okay? Now, for the last number, 25. The diagram shows 6 points, P, Q, R, S, T, U, equally spaced around circle of the radius 2 centimeters. The inner circle has a radius 1. The shaded region has 3 lines of symmetry. Okay, which of the following gives the area in centimeters squared? So if it has 3 lines of symmetry, so let's say it's this one, and this one. Basically, the areas of this are equal. Okay, now let's try to remove that. Let's focus on this part, this area. Now we have 6 sides, so we can actually find the areas in between them. For example, we know this area, we know this area, we know this area. Now first, what is the area of the shaded parts that we have? So that is pi 2 squared. And then what's the ratio? This is 1, 2, 3, 3 out of 6. Three out of 6. So basically, that is 1/2 of pi 2 squared. So basically, that is 2 pi. Now, we just need the other parts here. Now, we have a hint there. It could either be C or A, or maybe the rest, because we only have 2 pi. Now, these small triangles, let's see. Since this is 60 degrees, because 1/6 of 360 is 60, this means this one is 30 degrees. Now we know this is 1, this is 2. Now this should be, what do you call this? You should know the special angles here to solve this one. Because here, this triangle, you can actually find the area. Let's say if you have 31 and 2, you have 2 sides, you have the angle, you can find the area of the triangle, 1/2 AB sine theta, right? So in this case, it's 1/2, 1 times 2 sine 30 degrees. Now, special angle sine 30 degrees is equal to 1/2. So 1/2 times 1 times 2 times 1/2. This gives us just 1/2. So how many of this? We have 1, 2, 3, 4, 5, and 6. So 1/2 times 6, that's 3. So the answer should be 2 pi plus 3. Answer is letter A. Okay, now if you want to remember what are the special angles, you have to start 0, 30, 45, 60, 90. If you are going to use sine, remember sine 0 is 0, sine 90 is 1. We'll put the 2 here. So you start at 1, you know square root of 2, and you do square root of 3. If it's cosine, it's the other way around. So 1 square root of 3 over 2, square root of 2 over 2, 1/2, and 0. Okay, so that's it for today. Bye.